You're all able to hear me, right?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Okay, fine. Thank you. Uh, so I welcome you all for the session 2 of live interactive session for the course Polymers Concepts, Properties, Uses and Sustainability. I think three of you have joined and all three of you are new for this session, right? Before officially starting the session, let's have a brief introduction of each one of us. I'm Kritika. I'm a PMR scholar at IIT Madras and I'll be handling this live interactive session. So each one of you can just give a brief intro of your name and where are you from and what are you doing.
Hello, ma'am. Good evening.
Good evening.
My name is Paul, and I am a student at Christ University,
Okay.
and
Uh,
I'm studying this polymers as a part of my curriculum.
okay. Which course are you doing?
I'm doing
Bio.
biotechnology zoology.
Okay, fine. Thank you. Welcome to the course. Uh,
Thank you, ma'am.
Thank you. Uh, Mr. Sandeep.
Yes, good evening, ma'am.
Good
I'm
evening.
Sandeep Kumar,
Good evening.
and I am into shipping, into merchant navy, and I'm a chief engineer in merchant navy. Already completed my sailing in 2008, and after that, I've done my extra first class engineering from Government of India, DG Shipping, and I'm also MS by research from IMU, Indian Maritime University, and now I'm pursuing my PhD, for which this polymers is one of my coursework.
Okay. Oh,
So, so that's what. So
okay.
I'm yeah, quite old in this group, I think, but that's what. Yeah. Presently, I'm actually. I'm CEO in a company, shipping company in Vietnam. So right now I'm joining this from Ho Chi Minh City in Vietnam.
Oh, okay. We have an international student. Nice. Very
Yeah,
good
I
news.
mean, it's only been about 6 months since I'm in this place.
Okay.
So yeah, yeah.
Okay. So I welcome you to the course. In which field you're doing your PhD?
That's basically computational fluid dynamics and all
Okay.
for a centrifugal pump. Going for a different make and material of a impeller, possibly some type of polymer, and that's why this is one of the courseworks.
Okay. Okay. So nice. Okay.
Yeah.
We'll officially start the session. This session is going to be an interactive session. Uh, and I request all of you to actively participate in the session. You could give whatever answers you feel. It's nothing right and wrong. If it is going to be wrong, I'll be here to correct you. Okay, so don't feel shy in answering. Uh, and feel free to answer and also ask for any doubts possible. I request all of you to go through the lectures before these live sessions so that you can actively participate in the practice assignments as well. Uh, and then have your notebook, pen, and calculator. Uh, and yeah, uh, and that's it. So this session we'll be having a brief recap of weekly lectures, and then we'll also solve some practice assignment questions. So practice assignment questions will be a mix of numericals, conceptual questions, and also the questions will also be from GATE. So those who are interested in writing GATE examination, this will be giving a good insight as well. Okay. So, and also when I'm going to the PowerPoint mode, I request you to answer once in a while if you're there or not, so that I could ensure that I'm connected or not. Because once I go to the PowerPoint mode, I may not be able to know whether I'm there or my network is disconnected. And today, probably there may be slight disturbance in the connection because especially the the sound part of it, because there is some construction work going on. So whenever you're not able to hear me properly, please let me know. Okay. So let's
Yes, ma'am.
yeah, let's get on to the session. So are you all able to hear me and see my screen?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, let's get on to the session. Did you go through the lectures of week 2? Any of you?
Yes, ma'am.
Ma'am,
I
I'm
went
about
through
to
the
complete
lectures.
week
Sorry.
one.
Mhm.
Okay, okay, that's nice. That's good. Okay. Also, were you all able to solve the assignment 1 questions? Any specific doubts?
Uh, I did so, ma'am. Maybe some of them are still pending.
Okay,
So
okay. Okay,
yeah,
yeah, you still have time, I guess, 2, 3 days more, I guess.
yeah. My target is to complete actually by tomorrow because weekdays are slightly busy.
Okay, okay. So ensure that you complete the assignments, before the timelines as much as possible. And if you have any doubts, you can ask in this live interactive session. Also, there is a forum in the course page. So you can also type in your questions in the course page so that either myself or the professor in charge will be answering. I think there were few doubts asked in the last session. One was someone was one of the student. She was saying that the lecture 4 on biopolymers was incomplete. So we have informed the respective team, so they are working on it so that you will get the proper, complete video of that. And then there was also a question on the first question, which is on the molecular weight distribution, basically, where the student was saying that the graph was not discussed in the uh, uh, lectures. Last week itself I informed the student that there will be certain questions which will be a kind of homework that you have to search and find out. Not everything, not all the assignment questions will be exactly from the lecture. So you will have to put in certain effort and do some homework. So this is what I suggested her last week, and I also discussed with the professor, and he also suggested the same. Okay. So not all questions will be exactly taken from the lecture content. That is why you've been given references also, the course textbook, and also a lot of references after each lecture. So you have to go through those things as well, and also through other search engines as well, so that you are able to answer the questions. Not everything will be exactly from the lecture content. Okay. Now let's proceed. So before getting on to the practice assignments, we'll go through a uh, brief recap of lectures of week 2. So the lectures of week 2 were on simple concepts related to single macromolecule. Okay. So lecture 8, it was on renewable sources for polymers. This was based on sustainability. So here there was a discussion on sources of polymer, and what are the strategies for using renewable sources for polymers, right? And there was also a discussion on use of natural fibers. Correct? Do any of you remember any of the natural fibers that was discussed in the lecture?
Ma'am, I remember polyesters and
Natural fibers that were discussed.
natural in the sense jute, silk, and they were all discussed.
Yes, yes, correct. Jute,
Ma'am, I'm
scissor.
still going through the week two.
Okay,
Mine's not complete.
okay, okay, it's fine. So whatever you remember, you can just share. Okay.
Okay,
So
ma'am.
there was a discussion on jute, sisal, coir, and then from animal source also silk and wool were all discussed. Okay. And natural fiber composites, how these natural fibers are also incorporated along with the synthetic polymers, forming composites. Okay. This was also discussed, and examples of polymers from renewable sources were discussed. Okay, where there was a discussion on polylactic acid and polyhydroxybutyrate, and then polymers from renewable monomers were discussed. Here there was a discussion on again polylactic acid, and then polymerized by microorganism, which is polyhydroxybutyrate. So these things were discussed in lecture 8. You're able to hear me, right? Some drilling is going
Yes,
on. I just wanted to ensure you're able to hear me clearly.
yes, ma'am. We can hear.
Okay, fine. Yeah.
Yes, ma'am.
Yeah. So, and then lecture 9. Lecture 9 was on polymerization and depolymerization. This was again on the aspect of sustainability. So, polymerization method for each polymer were discussed. So, there was a discussion on the step polymerization and then free radical polymerization, ionic polymerization, and what are the new ways to think about polymerization, right? These were all discussed. And how is the molecular structure of biopolymers controlled? So there was a discussion on proteins, polysaccharides, what is their control mechanism in their molecular structure, were discussed. And then what are the in vivo and in vitro polymerization? And also there was a discussion on depolymerization, where enzymes like depolymerases, they work on the backbone of the polymers to biodegrade it. So there was a discussion on these aspects. Okay. Then lecture 9, it was on states of interest. So this was a concept based lecture where the concepts of physical state of polymers were discussed. So unlike your normal materials where you have solid, liquid and gaseous states, the physical states of polymers different from the normal nomenclature which we come across in a general material. So you have liquid like state, solid liquid like state, solid like state, and then the aspects of molecular interaction and temperature. So how does it makes the behavior change to more solid like or more liquid like? Those aspects were discussed. There was also discussion on solvation and plasticization. In liquid like state, there was a discussion on polymer solution and polymer melt. And then solid liquid like state, the discussion was on polymer gel and liquid crystalline polymer. And finally, in solid like state, there was a discussion on rubbery, glassy, and semi crystalline polymers. Correct? Right. So these were all discussed in states of interest, right?
Okay,
Yes,
ma'am.
ma'am.
Yeah. Okay. Next is lecture 11 was on application based terms. So it was on uses. So here the types of polymers based on applications were discussed. Okay. There was a brief on thermoplastics, thermosets, rubbers, polymers in electronics, fuel cells, batteries, sensors, and actuators. Right? Conducting polymers were introduced. Ionic polymers, polyelectrolytes, polymer charge complexes were introduced. Dielectric elastomers were introduced. And then there was a discussion on polymer solution, dispersion, and gels. And finally on polymer composites. Lecture 12, again, it was on reuse and repurpose. So this is again based on the sustainability aspect of the course. So here the definition of what is a linear economy and what is a circular economy, and the terms of ecological and carbon footprints were discussed, and the concept of reuse. How do you possibly reuse the polymers? And then what is the carbon footprint reduction due to recycle and reuse? So these aspects were discussed. Lecture 13, it was on molecular conformations. So it was again on concepts. So what is the conformation in a simple small molecule like ethane and butane was first introduced and discussed. Then the concept was further delved into macromolecules. So conformation of polyethylene was discussed. And then what are the role of conformation? Okay, in different states, there was a discussion on different states of polymers, right? In the previous lecture, it was on solid like and then liquid like, solid liquid like states, where there was a discussion on glassy, semi-crystalline, right, and rubbery state. So in these kind of states, what is the role of conformation playing? So this was discussed. And then the statistical properties of single macromolecule was introduced. So here the length and direction of vector connecting the first and last carbon atom was explained. And then what is the mean square end-to-end distance and the distribution of the end-to-end vector. So what is the type of distribution of end-to-end vector that was discussed? It's a normal distribution, right? The distribution of end-to-end vector for a polymer single macromolecule is a normal distribution. Okay. And then orientation of ith bond in a macromolecule. So these aspects were discussed in molecular conformation. The next lecture was on size, mobility and flexibility. So this lecture was on properties. So statistical properties of single macromolecule, where the concept of ideal chain and freely rotating chain were discussed. And then use or application of single macromolecule models. So size of molecules in solution, in overlap concentration, intrinsic viscosity. So these terminologies were introduced. Okay. And then flexibility of macromolecular segment. So the terms of rubber elasticity, swelling in polymer gels and viscoelasticity. So how the flexibility plays a role in these kind of aspects were discussed. Next, the concept of radius of gyration was brought in. And then the lecture dealt with shape of macromolecule, where molecules under shear, how does the shape changes, and similarly molecule under charge. The next was the expanded chain concept, where the excluded volume interactions were discussed. So this expanded chain concept of excluded volume is very similar to your van der Waals equation of state, right? Any of you who went through the uh, course, you could remember. Okay. Next, macromolecule as a Hookean spring, where potential for Gaussian spring and force, these were discussed. The last lecture of the week, lecture 15, was on polyelectrolytes. So what is an electrolyte and what is a polyelectrolyte? So these definitions were explained, and then examples of polymeric systems with charges which are not as a part of macromolecule. So these charges, because polyelectrolytes, they have charges and they tend to dissociate, right? In the presence of a solvent. So where there can be two types. One is the macromolecule itself is carrying a charge. The other is the macromolecule as a whole does not carry a charge, whereas it is associated with the component which has a charge. Okay. And then different applications of polyelectrolytes were discussed, and finally the sulfonated polymer in fuel cells, naphthalene, was discussed in detail, right? Are you all able to remember these concepts, or those who didn't go through, are you getting an idea what was all discussed?
Yes, ma'am. The
Yes, ma'am.
second option.
I'm getting a brief idea.
Okay, fine. But please go through
Yeah,
the lecture, because
of
there's a
course.
lot of effort put in by the faculty. Okay, please go through the lecture, because this course, it gives complete overview of polymers, the
Yes.
polymer physics. Okay, which is very very useful. Okay, so please go through the lectures. Okay,
Yeah.
and
Okay, ma'am.
maximum possible before the live interactive session, so that in case you have any doubts also, you can just ask in the live interactive session. Okay.
Okay, ma'am.
Yeah. So now let's get on to the practice assignment questions. Okay. So here I request you to be as much interactive. Okay. You can say whatever answer you remember when you have gone through the lectures or from your past learning. Okay. There is nothing right and wrong. If it is going to be wrong, I am going to help you in correcting it. Okay. Now let's start with the first question. So phenol formaldehyde resin is prepared by, it's a GATE 2024 question. Is it prepared by condensation polymerization, or by cationic polymerization, anionic polymerization, or ring opening polymerization? By which method of polymerization is phenol formaldehyde resin prepared?
Condensation, polymerization.
Okay, I've got an answer, condensation polymerization. What about others? Are you going with the same answer or you have a different answer?
I think same, but uh, yes, ma'am. Number one, A.
Okay, both of you are saying condensation polymerization. Correct, you're correct. It's condensation polymerization. So it is formed from phenol and formaldehyde condensation reaction where a water molecule is removed. Okay. So phenol formaldehyde is prepared by condensation polymerization. Okay. Now let's go to the next question. The estimation of the molecular weight of a polymer by gel permeation chromatography is based on is it based on polarity, or is it based on size, or is it based on adsorption to the stationary phase, or is it based on crystallinity? This is again a gate question. So can
Option B, size.
option B, size. Okay. So both of you agree with that, or any other option?
I'm actually not sure, ma'am.
Okay.
So,
Okay. So we have got one answer as size. You are right. It is size. So gel permeation chromatography is based on size through which you estimate the molecular weights. It is also called as size exclusion chromatography. Okay. The next question.
Ma'am, one doubt. Gel permeation means we are passing the polymer through a gel, right?
Yes, yes. So and based on the the molecular size, it may interact with the gel or depending on the the pores in the gel. Okay. So it may interact with the gel, it may get interacted with the gel depending on the molecular size. So if it is very large compared to the gel, gel structure, then it may not pass through the, it may not enter into the gel and it gets eluted fast. Whereas if it is of the right size or smaller size, it may interact with the gel and then
Ma'am,
get
what
eluted.
is eluted?
Eluted means it comes out. It comes out.
It comes out of the gel. Okay, ma'am.
Yes, yes, it comes out of the the chromatographic this one. One second, there is one more student joining. Elution means it's coming out of the chromatograph. Okay.
Okay, ma'am.
Yeah. I think we have one more student, Bhupati. I welcome you to the session. I think this is the first time you're joining for the session, right? Mr. Bhupati, are you able to hear me? Okay, there's no response. Okay, now let's go to the question number 3. So question number 3, the number average molecular weight of a polyester formed from equimolar mixture of adipic acid and ethylene glycol at a conversion of 99.95% will be dash. So what will be the number average molecular weight of polyester formed from adipic acid and ethylene glycol when the conversion is 99.95%? Okay. There was also a question in one of the earlier uh, you know uh, years when this course was rolled out. It was in 2022. A student named Shiva, he posted a question: how do you derive the number average molecular weight formula and how to know the repeat unit uh, weight per monomer? Okay. This was the question, and there is also a gate question which was very similar to this question. So the number average molecular weight again for polymerization of adipic acid and ethylene glycol when the feed ratio is 1:1, 99% conversion. Okay. So again, feed ratio 1:1 is nothing but your equimolar mixture. Okay. So this, when you solve this question, you will also get to know how to do this. The part 2 of the question that was asked by Shiva in 2022. Okay. So now how to go about this question? So you have been given that polyester is formed from equimolar mixture of adipic acid and ethylene glycol. and the conversion of that is 99.95%. So how do you find out the number average molecular weight?
Ma'am, is conversion rate the degree of polymerization?
It's not exactly the degree of polymerization, but it is related to that. So what type of polymerization is this actually? You have
It's ester. It's esterification. So it's a
yeah,
condensation polymer.
yes, it is a condensation polymerization. Okay, so now let's see how to solve this question. Okay, first of all, we'll have to start with the monomers. So we have adipic acid and ethylene glycol, right? So adipic acid, the molecular weight is 146.14 gram per mole, and ethylene glycol, the molecular weight is 62.07. Okay, so now you said that it is going to be a condensation polymerization, right? So what will
Yes, ma'am.
be the monomer molecular weight? What will be the monomer molecular
We,
weight in this case?
we will add the both monomer weight and subtract the weight of water.
Yes, perfect, perfect. Uh, so this is what is the reaction. So adipic acid reacts with ethylene glycol and a water molecule is removed and it leads to polymerization forming a polyester. So here actually two water molecule will be removed because to form the monomer unit, because here one water molecule will be removed, and similarly this side and this side, this OH and H will go off. Okay, so two more water molecules will be removed. So your condensation product molecular weight or the monomer molecular weight will be molecular weight of ethylene glycol plus molecular weight of adipic acid minus the molecular weight of water loss. So it will be nothing but your 146.14 plus 62.07 minus 2 into 18. Okay. So you will get a value of around 172.21 gram per mole. Okay. So 2 units of water is lost from a single unit as a functionality of both ethylene glycol and adipic acid are 2. You remember the concept of functionality from the week 1 lectures, right?
Yes, ma'am.
Yeah.
The possible
This,
number of ways.
yes, the functional groups basically. So adipic acid is having two H groups, and similarly, two COOH groups, and ethylene glycol has two OH groups. So each of them have two functional groups. So your functionality is two in both cases. Okay. Now the next step would be so this is the molecular weight. This 172.21 is the molecular weight of two monomers together, right? Two monomers together, this is the molecular weight. So what will be the monomer molecular weight of a single monomer? Because here two units condenses, correct? So
Yes, ma'am.
your molecular weight of the single monomer will be 172.21 by 2. So you end up with the monomer molecular weight of the single unit to be 86.15 gram per mole. Okay. Now the next is they have given conversion as 99.95. Okay. So converting into the fraction, you get P is equal to 0.995, and there is a relation for number average molecular weight and your conversion. Okay. So your number average molecular weight is nothing but your monomer molecular weight divided by 1 minus P. Okay. And your monomer molecular weight P of estimated, it's 86.115, and 1 minus P value they have given conversion is 0.995. So you will end up with the number average molecular weight to be, what is the value? It's given, it's 1,72,300 gram per mole. Okay. Are you all clear?
Ma'am, why are we dividing it by 2 to find the weight of a single
Because
monomer?
See, there are two monomers, correct? The two monomers are getting uh, in physical, there are two monomers. Adipic acid is a monomer, ethylene glycol is a monomer. Correct? So they are condensing to form a monomer. Right? So that is
Ma'am,
why
but both of them react to form the
condensation.
ester, but
Yes.
that is the repeating unit of the ester, right?
Yes. But still, technically, it's a single monomer conversion. Okay. So monomers means, see, for example, in your polyethylene, two ethylene reacts to form, multiple ethylene groups starts joining, correct? So
Yes.
it is actually technically in the start it will be one ethylene group plus another ethylene group. But you take and then that is what is forming a unit, right? For polymer, right? You can't take two ethylene as the molecular weight of the monomer, correct? But in reality, two ethylene group starts reacting, and then those two combined will react with another ethylene group. This is how the cycle goes. This similar fashion is also in case of condensation polymerization. So you have two monomers and then they react to form one monomer. So the single unit will be the molecular weights of both the monomers minus the molecular weight of the small molecule which is lost divided by the 2. You got it?
Okay, ma'am.
Yeah.
Yes, ma'am.
Yes, fine. Okay, are you all clear? Now can we move to the next question?
Yes, ma'am.
Okay, fine. Next question. Different dispersity is obtained when different polymerization methods are used for synthesis of polymers. Following are some examples of polymerization methods. Okay, natural protein synthesis, step polymerization, anionic polymerization, Ziegler-Natta polymerization. So against each range of dispersity values, enter the most appropriate polymerization method. Okay, now so different polymerization, you will end up with a different dispersity index. Okay, dispersity index you all remember, right? How the molecular weight distribution happens, whether it is
Mm.
monodispersed, whether all the molecules in the in the after the end of the polymerization are having the same molecular weight, or is it having different molecular weights, right? This was all
I
discussed
don't
in
know, ma'am.
week 1 lecture, the polydispersity index and monodispersed and polydispersed systems. Because polymerization you end up with large molecules, right? So after the polymerization in reaction, all the macromolecule units formed will not have the same molecular weight. It will be a molecular weight distribution. Okay, so this molecular weight distribution, if it is narrow distributed, or if it is, if it is all the molecular weights are same, then it is called as monodispersed system. But in reality, you will not end up with a monodispersed system, but you will end up with a polydispersed system. But how much polydispersed it is, okay, it is to be estimated. Okay, so that we, for further understanding the, polymer properties and behavior and all, this polydispersity index will be very useful. Whether the distribution is very narrow or it is a very spread distribution. Okay, see, for example, I can have 10 molecules of polymer that has formed as a product, and these 10 molecules, if all the 10 are having different molecular weight, then the polydispersity is high. But if I have 6 to 7 are having a molecular weight of 10,000, and remaining 2 3 are 15,000, then the dispersity is lesser. Okay, you got what is the polydispersity, right? Hello.
No, ma'am. Can you repeat?
See, when polymerization reaction takes place, okay, in real life, okay. So, for example, polyethylene is formed. You take ethylene monomer and then you end up forming polyethylene after a polymerization reaction. The polyethylene formed, there will be multiple molecules of polyethylene, correct? In the
Yes, ma'am.
product. So these multiple molecules, is it necessary that all will have the same molecular weight, or in other words, will all these polyethylene molecules, have same degree of polymerization?
There are many, right?
They
There
will.
won't be.
Yes. So the degree of polymerization will not be same for each molecule. So there is a distribution of molecular weight, correct? There is a distribution of degree of polymerization, right? One molecule will have 10 units and another molecule will have 30 units, right? And another one will have 100 units. So this is what we say as dispersity. Okay. If
Okay.
all the 10 molecules, if they are having 10 units in each of them, then it is called as monodisperse. But if one is having 10, one is having 100, one is having 50, one is having 30, then it is called as polydisperse. Okay. And
Okay.
if this differences is more, say for example 10 molecules having 10 different molecular weight, then the distribution of the polydispersity is high. Whereas if I have out of 10, nearly 8 molecules, they are having 10 monomers in them, and two have like 20 monomers in them, then the dispersity is less, right?
Okay, ma'am. Understood.
Yes. So now the question is, in different type of polymerization, what will be the dispersity? Okay. So there are four types of polymerization given, and they have also given the dispersity index value. So they have given 2 to 4, 2 to 40, 1, and 1.02 to 1.5. Okay. Now the question is, which type of polymerization will give what kind of dispersity at the end of the polymerization? So what does natural protein synthesis give? What kind of a polydispersity does a natural protein synthesis give?
Right. Maybe one,
Why do you say it is 1?
because dispersity is less because almost all protein molecules all have the same number of amino acids.
Okay. Okay. Does any of you have any other answer, or can we go ahead with this answer? You can give your answers. There is nothing right and wrong. Okay. It's going to be a learning. Okay. What about step polymerization?
Step polymers, I have no idea.
Okay. Anionic polymerization?
Anionic polymerization, I would say it is 2 to 40 because they uh, the dispersity will be high.
Okay. And what about Ziegler-Natta?
Ziegler-Natta, I have no idea.
Okay. Now let's see what is the answer is. It is actually step polymerization. They have the polydispersity index ranging from 2 to 4. Ziegler-Natta 2 to 40. Okay. Protein synthesis, as you said, it is 1. So natural polymers, we could see how beautiful the nature is, that they give almost a monodisperse system, especially in case of proteins and nucleic acid. Your DNA also, uh, you have, your system to be close to monodisperse. Okay, their molecular weights are very exact. And finally, anionic polymerization also gives a dispersity close to 1. Okay, now,
Okay, ma'am.
yeah, now let's go to, okay, there is a sub question again in the same category. This was asked in GATE 2008. Among the polymerization methods listed below, the one that is likely to give a polydispersity close to unity is it anionic, cationic, condensation, or radical polymerization?
I have no idea.
Just now we saw what is the
Anionic,
values. Huh?
anionic,
Yes, it
close
is
to one.
yes, it is anionic. Anionic polymerization is also called as living polymerization. So here you will have your polydispersity index to be very close to 1. Okay, that is what we saw 1.02 to 1.5. Right? Yeah. The next question.
Okay, ma'am.
So, following is a list of some applications of polymeric systems in electrical and electrochemical applications. Okay. So we have battery electrolyte, proton exchange membrane in fuel cell, separator in battery, gel electrolyte. Okay. The next list describes polymeric systems that can have ionic conductivity. Swollen networked polymer, sulfonated polymer, polymer charge complex, and porous polymer with electrolyte in pores. Okay. The first four are the polymeric systems, and the next four are their ionic conductivity and they how they are in nature. Like they may be a swollen networked polymer, or there may be a sulfonated polymer, polymer charge complex, or a porous polymer with electrolyte in pores. Okay. Now you have to match the following polymer with the polymeric system and their application. Okay. The first four represented the application, whether it is used in battery electrolyte or proton exchange membrane or as a separator in battery or a gel electrolyte. Okay. The next four are the polymeric systems. Okay. Which can be used in any of in the earlier listed four applications. Now you have to match the polymer names which I am saying to these two. First is Nafion. What kind of polymeric system is that? Is it a swollen networked polymer, or is it sulfonated polymer, or is it a polymer charge complex, or is it a porous polymer with electrolyte in pores?
I don't know, ma'am.
Okay. Anybody else? You can just make a try. Anybody else wants to give a try? Second one, concentrated polyethylene glycol with salt. What kind of a polymeric system is that, and what kind of application it is used for?
I,
Battery,
Which one?
battery electrolyte.
You're saying concentrated polyethylene glycol with salt.
Yeah,
Okay. 1 second, just hold on a moment. Okay, so you have said concentrated polyethylene glycol with salt is used as a battery electrolyte. Okay, what kind of system is that? I'm not saying your answer is right or wrong, but I'm just asking the second part of the question. What kind of system is that? What kind of polymeric system is that? Is it a swollen networked polymer, or is it a sulfonated polymer, or is it a polymer charge complex, or is it a porous polymer with electrolyte in pores?
charge complex.
You're saying concentrated polyethylene glycol with salt is a polymer charge complex. Okay. And you're saying it is used as a battery electrolyte. What about others? Do you agree with that? You can also, check for the answers for what polypropylene with KOH and lithium salt and polyethylene oxide. What kind of polymer system is it, and what kind of application is it used for? So far, I've got one answer. I'm not saying whether it is right or wrong. The answer told was that concentrated polyethylene glycol with salt is a polymer charge complex, and uh, it is used as a battery electrolyte. I want what are the answers for the other, uh, you know, other questions, including this. If you have any other answer, anybody else have any other answer, you could say that. This is actually a direct question from the lecture 15. You want to think for a few more minutes, or shall I proceed with the answers? You want to take a guess?
The separator in battery, ma'am, that may be this KOH one also.
Okay.
Uh, Polypropylene with KOH.
Okay. You're saying that is a separator in battery. So what kind of polymer
Mhm.
system is it?
Neutral
You have been
porous
used.
polymer, porous polymer with electrolyte in pores.
Okay, you're saying that as an answer for polypropylene with KOH is a porous polymer with electrolyte in pores, and it is a separator in battery, you're saying. Okay. You want to try out for the remaining two? And do you want to change any of the answers what you have given, or shall I proceed with the answers?
Yes, ma'am, you may proceed. Actually.
Okay. What about Paul? Shall I proceed with the
Yes,
answer?
ma'am.
Okay.
Yes, ma'am. Please proceed.
Okay. Now let's proceed with the answer. So Naphion, it is a sulfonated polymer. Okay. So the structure will be very similar to your Teflon structure, CF2, but it also has, an extended, in the branch, your sulfonic acid group, SO3H group. Okay. And this is extensively used in proton exchange membrane in fuel cell. So this allows, passing of protons, your H plus ions through them. Okay. Which is used in fuel cells. Okay. The next one is concentrated polyethylene glycol with salt. It is actually a swollen network polymer. Okay, and it is a gel electrolyte. Okay, this polyethylene glycol has a nature of getting swollen. Okay, with salt, and it's used in gel electrolyte applications. Next, polypropylene with KOH. As you said, it is a porous polymer with electrolyte in the pores. The KOH is in the pores present in the polymer. Okay, and it is used as a separator in battery. And finally, lithium salt and polyethylene oxide. This is actually the polymer charge complex, and this is used as a battery electrolyte. So this system, the polyethylene oxide as such doesn't have any charge, but the lithium salt has a charge, and this dissociates, and it can be used in the your battery electrolyte. Fine. This is actually
Ma'am, is lithium salt and polyethylene oxide used in lithium ion battery?
I think I don't know
Okay,
whether
ma'am.
they're extensive application, but I think these are all kind of alternatives that are being tried out. I'm I think for lithium ion batteries, they have been attempted. I don't know whether it is in commercial use. I'm really not sure. I'll get back. Okay.
Okay.
Yeah. Next, electronic conduction in polymers is due to Why there is an electronic conduction in polymers? Do polymers have electronic conduction?
Formation of
Formation of?
ions
That is ionic conductivity. What about electronic conductivity?
due to presence of free electrons.
Why do we have free electrons?
Because that is the main cause of conductivity, electron.
Okay. How does it have free electrons? What makes it to have free electrons, the polymers?
I don't know.
Okay. Uh, okay, let's see what is the answer. It is actually not free electrons but delocalized electrons. Conjugation. Conjugation is nothing but you've seen benzene ring, right?
Yes, ma'am.
So in benzene ring, you will have alternate single and double bond. Correct?
Yes, ma'am.
Yeah.
Yes.
So you can also, represent benzene ring by a hexagon with a circle inside. Correct?
Yes, ma'am.
Yeah. So why do you represent it by circle? Do you have any idea?
I have learned in my 12th grade because the double bond always position changes.
Yes, that is nothing but your delocalization of electrons. So there is no fixed position of the double bond. The double bond can be between any of the CH groups. So that is what is called as delocalization of electrons. So in polymers also, in certain polymers like polyaniline and all, this kind of a alternate single and double bond conjugation is there. And this is what causes electronic conduction in polymers. This is not true in all polymers, but in certain polymers which have these conjugations. Okay.
Okay, ma'am.
Yeah. The next, identify the correct statement. The orientation correlation is strong for large I and decays to 0 for small I. The orientation is correlation is strong for small I and decays to 0 for large I. Or the orientation correlation follows normal distribution with 0 for small and large I and maximum at a particular I. Or the orientation correlation does not vary with I. So, which of the statement is correct?
Ma'am, I is like what is meant by I, ma'am?
I represents the link, the particular, the initial, group.
Okay.
The polymers have, it's a large chain, right? So each, monomer or a particular set of monomers is represented by I and they are connected.
Got
So
it.
if you, the question is, since the monomers are all connected, right, they can have any different type of orientation, right? There's a CC bond
Yes.
connections, right? So the first CC bond, sorry, C bond is represented by 1 and there are so many CC bonds, right? So if I know the first, CC bond orientation, can I find out the orientation of, some nth CC bond? And how is that, orientation I can correlate with? So will that, the correlation, is it, that it is strong? I can find out how does, the orientation of that particular ith bond is, if the I value is small or if the I value is large. Whether there's correlation or whether I can predict how it will be oriented. Say for example, I have 1 to 100, okay, links of CC bond. So I have a particular orientation of the first bond. So will I be able to figure out in a better fashion how the orientation of the 10th bond will be, or will I be able to figure out in a better fashion how the 100th bond will be, which will have a better correlation?
So I think, ma'am, out of these choices, C, as far as what you have explained, looks fine.
Okay, you're saying that
Normal
it
distribution. Yeah,
follows the normal distribution. Okay, okay.
with zero for small and I mean, at one particular eye, it may be more, just a thought.
Okay, I've got one option. What about others? What do you say?
Ma'am, I would tell it is option D.
D, you're saying that does not vary with I. Okay,
No,
so
B.
B, that is the orientation correlation is strong for small I and decays to
Yes, ma'am.
0. Okay, so let's see what is the answer. So as Paul said, it is option B. The orientation correlation is strong for small I and it decays to 0 for large I. So closer the I value, so I can correlate it better. I can find the correlation of how the orientation will be for a second link compared to the 100th link. Okay, because the polymers follow more of a random, uh, uh, you know, orientations, a random walk model. So I could correlate better if the I is smaller, and the correlation starts declining as the I goes larger and larger. Okay,
Okay, ma'am.
Mr. Sandeep, you are able to get it?
Yes, ma'am. Got it,
Oh,
ma'am.
yeah. Okay, fine. Now let's go to the next question. Identify if the statement is true or false. Lignin is degraded by few and special microorganism and at low rates. Is it true or false?
True.
Both of you agree with that?
Because I believe lignin is found in wood, old wood, which will take many time to degrade.
Okay. So what about Mr. Sandeep? You are also agreeing with that?
Yes, ma'am.
Okay, both of you are right. Yes, it is true. Lignin, though we say it is a natural polymer, its rate of biodegradation is very slow. Okay, next. Control of molecular structure in proteins and polynucleic acid is in terms of its what? What controls the molecular structure of proteins and polynucleic acids? At least you can relate for proteins. This one term, comes very frequently when you say of, synthesizing proteins and all. What is that?
Some choices, ma'am. Amino.
Okay. So I'll say certain options. So is it branching? Is it stereo or regioisomerism? Or is it, the sequencing? Or is it all the options?
I am, I would think it is sequencing.
Okay. What about the others? Are you also agreeing with that?
So, ma'am, seems like sequencing, but not sure actually, frankly.
Okay, it is actually sequence. So, in case of proteins and polynucleic acid, it is the sequence which controls the molecular structure. Whereas when it comes to your polysaccharides, there are also aspects of your branching, and then the stereo and regio isomerism and sequencing all plays a role in controlling the molecular structure of polysaccharides. That's why in case of proteins and polynucleic acid, you get much more of a monodispersed system, and a closer single molecular weight, whereas in case of a and narrow distribution of molecular weight, whereas in case of a polysaccharide you will have a molecular weight distribution. Okay, this is again taken directly from your lecture only. Okay, let's move on to the next question. Thermosets are dash cross-linked compared to elastomers. This is about cross-linking in case of thermosets and elastomers.
Uh, I am not sure about it, but I think it's less.
Thermosets are less cross-linked compared to elastomers, you're saying. Okay. So both of you agree for that?
Yes, ma'am.
They are less cross-linked, you're saying. It's actually the other way. Thermosets are highly cross-linked. Okay, that is why it's thermoset. There is no flexibility. Whereas in case of your elastomers, there is a lot of flexibility because the cross-linking is very less. Okay, and you have a good segment and mobility in case of a elastomer, especially between the cross-link. Okay, if the cross-links are lesser, they are distributed at a longer distance. So the segments between the cross-link will be longer, right? And that is why, they are more flexible. Whereas in case of thermosets, the cross-linking is very high. Okay. Now, next question. The polymer chain conformation indicating a good solvent is what would be the molecular conformation of the polymer if the solvent is a good solvent for that particular polymer? Will it be a random coil, or will it be an extended, or will it be an ideal chain?
I don't know.
Okay. So, Mr. Sandeep, you want to try for an answer?
Random maybe, ma'am, or
So, you're saying it will be random, coil-like structure, more coil-like structure, you're saying, if it is a good solvent.
I'm not sure, ma'am, actually.
Okay. It's okay. You're saying this as an option. It's actually, it will be an expanded chain conformation because, see, random coil structure, if the solvent is bad, there is not much interaction between the solvent and the polymer molecule. So the molecule tends to be in more of a coil-like shape. It interacts with itself. Whereas when the solvent is very good, there is a good solvent and polymer interaction. So the chain tends to open up and expand. Okay? You are able to get it?
Okay.
Yeah.
Yes, ma'am.
Yeah. Next. Molecular interaction in starch is dash compared to polyethylene due to dash. Is it stronger or is it weaker? And why is so? Similarly, the next.
I'm
Yeah, yeah.
telling more in starch compared to polythene due to branching,
Is it due to branching?
because branching is more in starch.
Okay, you're saying that way. Okay. Let's read through this next part of the question also. Molecular interaction in polystyrene is dash compared to that of polyethylene due to dash. Whether it is stronger or weaker, and then why?
It is weaker than polyethylene due to huge size of benzene.
Okay. So, Mr. Sandeep, you want to give it a try?
Not sure, ma'am, actually. Yeah.
Okay, that's okay. So let's see what is the answer. So the molecular interaction in starch is stronger, as you said, compared to polyethylene. It is due to actually not branching, but it is due to the hydrogen bonding. Okay. In starch, you have a lot of hydrogen bonding compared to the polyethylene. The next is, again, in case of polystyrene, the molecular interaction is stronger compared to polyethylene. It is because of, as you said, benzene. It is a bulky side group compared to your polyethylene. Polyethylene, you have the side groups as hydrogen and hydrogen, whereas in case of polystyrene, you have benzene ring in as one of the side groups. So because of that bulkiness, it has a stronger molecular interactions. Okay. Now next, ecological footprint is estimated in terms of dash, while carbon footprint is estimated in terms of dash. In what terms do you estimate ecological footprint and carbon footprint? At least carbon footprint you can answer. It's almost very general. You can find it out.
It is estimated in terms of CO2 emission.
Okay. So what about ecological footprint?
And it will be the production of carbon compound.
Okay.
I'm not sure, just a random guess.
Okay. That's good. That's good. You're making an attempt. That's good. Now let's see what is the answer. Or Mr. Sandeep, you want to give it a try?
Carbon footprint, I agree, ma'am. That's
Oh,
the amount of carbon dioxide that's emitted.
okay. What
Yeah,
about what
physical,
about
I think that's more to do with uh, the human demand on the capital, but I'm not sure the unit of measurement actually.
okay, okay, fine. No issues. Let's see what is it. So ecological footprint is estimated in terms of equivalent land units. Okay. And carbon footprint is estimated in terms of, as you both said, it's in terms of CO2, total greenhouse gases in terms of CO2. Okay. This is what is the ecological footprint definition. It is an indicator which can be used to track the past and current human pressure on the biosphere's capacity to provide life supporting and regulatory ecosystems, products and services. So it is equivalent it is estimated in terms of land units. Okay. This is taken directly from the lecture. Okay. Now let's proceed to the next question. The mean square end-to-end distance calculated from freely rotating chain model of polyethylene is dash that of calculated from ideal chain model. Is it same, or is it double, or is it half, or is it triple? What is the mean square end-to-end distance for polyethylene from a freely jointed chain model and an ideal chain model? Any guesses?
I would tell it is double.
Double, you're saying. Okay, so Mr. Sandeep, do you also agree?
I think so, ma'am. Yeah.
Okay, let's see what is the answer. Yes, you are right. It is twice. So in case of ideal chain, your mean square end-to-end distance is given by ns into a square. Whereas in case of your freely rotating chain, your angle between two subsequent bonds comes into picture, and this bond angle for in case of polyethylene is 109. Okay, so when you and the cos theta of this 109 is minus 1 by 3. If you substitute that, you will end up with the mean square end to end distance for a freely rotating chain model in case of polyethylene is 2 times that of the ideal chain model. Okay, now let's go to the next question. Modulus of rubber dash with temperature. Does it increases with temperature or decreases with temperature or does not vary with temperature,
Ma'am,
or
it
it
decreases
decreases? Okay,
because its elasticity decreases with temperature.
okay, so both of you agree in that it decreases with temperature, you're
Yes,
saying?
yes, ma'am.
Okay, it actually increases with temperature. And this is the concept of rubber
Oh,
elasticity. So if you just understand the concept of the Hookean spring, you could see that the spring constant, uh, can be correlated to the if you in terms of stress and strain. So if your force is equated to your stress, your spring constant becomes your modulus, and your displacement becomes your strain. Okay, it's just changing the force to stresses, right? So then your spring constant here, it is given by 3 RT by R square. So that means your spring constant is directly proportional to temperature. That means your modulus is directly proportional to temperature, which means that when the temperature increases, it is the modulus also increases. Okay, this comes under the theory of the rubber elasticity, which is an entropic elasticity. Okay, I hope you got it. Now let's move on to the next question. Role of conformation in terms of macromolecular motion. That is, the whole molecule moves, happens in dash among the following. So where does the whole macromolecular motion in terms of conformation change happens? Does it happen in rubber? Does it happen in polymer melt? Or does it happen in glassy polymers? Does it happen in crystalline polymers or in polymer solutions? In which case, there is a whole macromolecular motion happening.
Ma'am, I would tell it is polymer solutions.
Polymer solutions, you're saying. So, both of you, do you agree with that? Or you
ma'am,
want to?
actually, this role of conformation means behavior for the entire macromolecule, or how, what they want to ask.
See, the role of conformation is, see, the macromolecule changes its shape and orientation and all. So it can be through whole molecular motion or it can be through some segmental motion and all. But in this particular question, what is asked is where does there is a whole molecule motion happening? In which case there will be a whole molecule motion happening. Does it happen in rubbers or glassy polymer or crystalline polymer or polymer melts or polymer solutions?
I'll go with Paul then.
Okay, you're saying polymer solutions. Okay, let's see what is the answer. It's actually polymer melts and polymer solutions. In both these cases, there will be the whole, macromolecular movement. Okay. In case of rubbers, there will be a segmental mobility. Whereas in case of glassy and crystalline materials, there will be some bond vibrations. Okay. But in case of polymer melts, Okay. And in polymer solutions, the whole macromolecule uh, can move. And in case of polymer melts, it is called as the reptation movement. Okay. Something like a snake-like movement because there are multiple molecules entangled. Okay. Hope you got it.
Okay.
Yeah. Next question. Identify natural composite from the following: cellulose, nylon, jute thermoplastic composite with LLDPE, and then wood. Which one is a natural composite? I think one of you told some something early in earlier questions.
I would tell it's wood.
Okay. Both of you agree with that? Or you have
Yes,
some other
ma'am.
on? Yes, you are right. It's wood. So wood is a composite of cellulose reinforced in lignin. So wood actually it has some amount of hemicellulose as well. So it has lignin, hemicellulose, and cellulose. Okay. This is what is the structure of lignin, cellulose, and hemicellulose. Fine. Now let's proceed to the next question. At liquid nitrogen temperature, thermal energy available is dash for bond rotational and conformational changes, making the molecule more brittle. So, is it more or is it less or is it very equivalent to what is at room temperature?
Less.
Both of you agree?
Yes, ma'am. Less.
Okay. Yes, you are right. At liquid nitrogen temperature, which is a very, very low temperature, I think it's minus 192 degrees centigrade. So at this temperature, the thermal energy available for bond rotation and conformational changes is very, very low. So because of this very low thermal energy available, the molecules are frozen and the frozen molecules behave more brittle. Okay, that's why anything you immerse in liquid nitrogen, it becomes more brittle and it starts shattering. Okay, even if you just immerse a leaf into it, you can just break it into pieces like a glass piece. Okay, it becomes more brittle, right?
Ma'am, what was the temperature again? Liquid nitrogen.
I think it's minus 192 degrees centigrade if I'm not wrong.
Okay.
Yeah, it's very low temperature. See, at room temperature your nitrogen is gaseous state. So if it has to be in a liquid state, the temperature has to be very, very low. So that means the thermal energy in that temperature will be very, very less. That is why the molecules get frozen and there will be no scope for bond rotation and all, and there will not be any conformational changes that is happening, and that is why the molecule become more brittle and it tends to shatter if you just try to break it. Next, bulky groups along the backbone in polyether-ether ketone supports in existing in more coil-like conformation. Identify if the statement is true or false. Polyether-ether ketone has bulky groups in the backbone. Okay, so does that make the polymer to have more coil-like conformation? So does that support more coil-like conformation, the presence of bulky group?
I would tell it's true.
You're saying it is true. So the molecule, if they have bulky groups in their backbone, they'll tend to form more of a coil, you're saying.
Yes, ma'am.
Okay. So Mr. Sandeep, do you agree?
I'm not sure, ma'am.
Okay. Let's see what is the answer. It is actually false. So polymers with more bulky group along their backbone, they tend to occupy more extended or rod-like state. See, because of the bulky, so if you just look into the structure, because of these bulky groups, no, it can't have a more of a rotation between, the carbon-carbon links, right? So it cannot coil itself. So coil-like structure means you can imagine the noodle, right? In noodles you have, it is more coiled, right? That kind of a coil-like structure, if the groups are very bulky, heavy groups, it cannot, form a coil, right? It tends to be more of an open structure. Okay, it will be more
Okay,
of
ma'am.
an extended structure because of the rigidity this bulky groups give. Okay, now next question. Blending of waste polymer with other polymers using a suitable compatibilizer is a method of industrial reuse. Is it true or false?
True.
So you're saying, what about Mr. Sandeep? Do you also agree? Is it a method of reuse in industrial level?
Yes, ma'am. True.
Yes, you are right. It is true. So there are different types of industrial reuse that can, that can be done. So one is direct recuperation of scrap during molding. The second is blending of waste polymer with other polymers with a suitable compatibilizer. Okay. So it needs some compatibilizer, some third component to blend it with. And then mixing with various additives such as antioxidants or reinforcing agent can also be an industrial reuse method. And then modification of the polymer structure to recover its original properties. So these waste polymers, they may not have the original properties. That is why, it goes into waste. So to recover its original structure, some modifications can also be done and then reused. So these are some of the reuse methods in industrial level. Okay. Next. Radius of gyration gives an idea on the extent of macromolecule from its center of mass. Okay. For an ideal chain, radius of gyration is related to mean square end-to-end distance as, how is it related? So is it, radius of gyration is 1/4 of the mean square end-to-end distance, or 1/2, or twice, or 1/6, or 3/4, especially in case of ideal chain. How is it correlated?
Mm, I'm not sure, ma'am.
Okay.
But I will tell it is option D, 1/6 of the mean square end-to-end distance.
Okay. So both of you agree on that, or you have some other option, Mr. Sandeep?
I'm not sure of the formula right now, ma'am. But I know it's that ensemble average to mean square end to end, but maybe 1/6 is correct.
Okay. Yes, it is actually 1/6 of the mean square end-to-end distance. So this is how it is. So actually radius of gyration, it gives an idea of how much volume does a macromolecule span and what is the extent of macromolecule from its center. And for an ideal chain, it is related to the end-to-end distance as r naught square by 6. Okay. Uh, so that's it with the practice assignment question. So I'll just have a brief discussion on one of the questions posted in the forum in July-November 2022. Okay. This gives you an idea that you can post whatever doubts you have in the forum and it gets answered. Okay, which will be useful for you and for others as well. Okay. So the question was, at room temperature, polyethylene and polystyrene exist as plastics. Natural rubber, NBR, SBR exist as rubbers. But biopolymers such as proteins, polysaccharides, polynucleotides, how do they exist? This is the question. Do you have any idea? How do they exist? These natural polymers?
Solids.
You're saying solids. Okay. This was the question posted by one of the students. So let's see what was the answer suggested by the professor of the course. So what he has given is that, see, first thing he is given a correction also. Polyethylene at room temperature, it is not a plastic. Okay, it is in rubbery state. Right, your polyethylene bags are all very flexible, right? That means it should be in a rubbery state. Okay, and biopolymers, it can exist in one of the following states. Okay, so biopolymers, they can be dissolved in aqueous solution, so they can be macromolecules or solubilized in this case, implying that very close interaction amongst the solvent and polymer molecule. They can be aqueous dispersion also. For example, if they are having a crystalline state, especially in case of proteins and all, no, there will be a certain amount of crystallinity also, or partially crystalline state, implying some portion of the macromolecule as crystalline and some other portion are solubilized. The amorphous phase, probably is solubilized. That is why you end in some aqueous dispersion state. They can also be in solid state, as you said. So powder form, crystalline form, or amorphous form. It can be either form. It can be. And then if they are in amorphous form, most likely they can be dry polymers with a will be in glassy state. However, water can plasticize and reduce the glass transition temperature in these polymers. Okay. So glass transition temperature, you will get to know about this in lecture 22 and 23. Plasticized biopolymers will be in rubbery state. So in amorphous state also, they can be in glassy or rubbery state. So if they are in glassy stage, they are mostly very dry biopolymers. But if there is a certain amount of water present, they can plasticize the biopolymers and make them in a rubbery state as well. So as such, you cannot clearly define what will be the state of biopolymers in. So what is the it depends on what is the environment it is in. Okay, so based on the environment it is in, the state also varies. Okay, this is what is the answer provided by the professor of this course. Okay, so you can understand how in-depth answer is given, okay, with all perspective in place. So similarly, if you have any questions, you can post it in forum. You can also ask in the live session like this we have. Okay, and also please go through the lecture, uh, you know so that you will get maximum information possible. You will also get to know, you will also start getting some doubts which you can ask in either forum or in the live session. Okay, thank you.
Ma'am, will there be more live sessions like this?
Yes, see,
Uh,
every week Saturday 4 to 6 there will be a live session. Okay, for all the 12, the course is of 12-week course, and for every week there will be a live session, and just before your exam there will be a consolidated live session also. Okay, so try to attend the live session, and this will happen every Saturday from 4 to 6.
Okay, ma'am.
Thank you, ma'am. This was really very helpful, actually.
Yeah, yes, ma'am. It's
It was,
helpful.
yeah, correct. It was more helpful than, trying to slog through the slides, actually. Uh, Ma'am, and what is the actually for this pass marks and all that? If you can just tell on this one, because for me it's the first experience.
Yeah, I'm really not sure of the pass marks and all,
Okay.
but there is a requirement that you have to complete these many assignments. So there will be, since it is a 12-week course, you will have 12 assignments, and out of 12 assignments, I think you should have done, I think, 8 or 10. I'm not sure. Um, Maybe the NPTEL team may be able to answer on this better. Uh,
Okay. Each assignment also carries some sort of a passing mark because there are varying questions. Some of them have 20, some of them sometimes have 10 or 11. So it's again based on percentage, possibly.
sure whether each assignment is kind of a pass or fail, but you will be given some markings. I'm really not sure of individual things. Maybe I can just
Okay.
check with the NPTEL team, or you may be getting some intimation from the NPTEL team as well. Okay, you can just check the course announcement page as well so that you can get the updates. So you get updates
Okay.
on when the interactive session happens, when the lectures of the particular weeks are published, and all those things you will get to know. And you can also post it in the forum so that the NPTEL team can also answer these questions. I'll also get in touch with the NPTEL team to get to know on this. Okay. So
Okay, ma'am.
is there any other doubt?
Uh, Not for now, ma'am. Thank you.
Okay, okay. So if you have any other doubts, you can post it in the forum or you can ask in the next session as well. So we'll try to answer. If not in that particular session, I'll note down your question and then answer in the following session or answer through the forum also. Okay. And do you want any improvement in the session? Whether you want more numericals, or the speed is fast or too slow, you want any content improvement in the session. So those things also you can say now or you can post it in the forum as well.
Sure, ma'am.
So if you want more questions also, please let us know so that we can modify the live session as well, to take it to a better format so that more students also join. Okay.
Yes, ma'am. One feedback will be, something like if I'm sure it's already there, but possibly if it is more targeted towards the exam questions, I'm sure everyone will join.
So it is actually these are all, again, this is all taken from your
Good.
lecture and some gate questions only.
Wonderful,
And
ma'am.
this is actually designed, this live sessions are actually designed for helping you to answer the assignment questions better. Okay.
Definitely, ma'am.
So that is the purpose of these questions. So that is why I'm trying to mix conceptual questions and also some numericals also, and I'm also trying to take from gate questions as well. So whatever possible, and I'll also try to improve it with more of a logical reasoning and whatever possible, why this particular aspect of behavior is like this. Say for example, uh, the bulky side groups has more of an extended conformation. So that kind of a reasoning also will try to add on that when discussing the answers also. Okay. So
For this subject, ma'am, any book or you would recommend, or these notes must be sufficient, but
I think in the course page, there are certain books and reference books mentioned. You can just go through
okay.
that. And also, after every lecture, there are a set of references that are also mentioned. Either it can be a book or paper also from where the contents are taken. So if you want
Okay.
to further,
Okay.
have a deeper understanding, you can go through those references also. Okay?
Okay, ma'am.
Yeah.
Okay.
Yeah.
Got it.
Okay. So if there are no further doubts, then we can officially end the session. Anything else you want to say?
Yes. No, ma'am. That's all from my side.
Okay, fine. Thank you. Have a nice weekend.
Thank you, ma'am. Same to you.
Thank
Okay,
you.
thank you, ma'am.
Thank you.